Hello everyone, I am Akhilesh Kumar Shrivastava from ABS Engineering College, Ghaziabad. In the series of operating system lectures, we have started with the mass storage management on the last turn. We have seen that the hard disk is responsible for storage of the files and the data, which will then be executed while bringing it to the RAM. For effective utilization of the space and for fast access, we do store the elements or the data or the files on the hard disk in some defined manner. As a part of the formatting, the operating system divides the entire disk space into the tracks and the sectors, and the sectors are the basic unit of the storage of the data. In today's lecture, we will see some of the disk scheduling algorithm, and we will see that how can the operating system control the movement of the disk arm. The outline of today's lecture will be, we will first have a re-look at the disk structure that we discussed on the last turn, and then we will see the disk scheduling algorithms. Now, this is the part that we have seen on the last turn. We have seen that a hard disk will contain some platters. These are the platters, and the data can be stored on both sides of this platter. It means data can be stored on the top side and the bottom side of the surface as well. In case we have n number of the disk platters, then usually 2n surfaces will be there, and the data can be stored on 2n surfaces. But in some of the disks, the data is not stored on topmost surface and the bottommost surface. So hence this total usable surfaces will be 2n minus 2 in that case. Now all these platters are connected to a spindle, and this spindle moves, and when the spindle moves, the disk platters will also move. Usual speed of the movement of the spindle is 3600 revolution per minute or 5400 revolution per minute. There is a fixed read-write head for each of the surface. It means the dedicated read-write head is available for each of the surface for performing the read and the write operations. This head usually moves in and out continuously, but in some of the hard disks we deal with, or we have the head one for each of the track. We will discuss what is the track just now. It means the head is fixed. So there are two kinds of the heads available. One is the fixed head and the other one is the movable head. In practice, the movable heads are preferred over the fixed heads. As a part of the formatting, the operating system will divide the entire surface into the concentric circles known as the tracks, and we store the data on the tracks. But before the storage, we can see that the tracks are divided into the equal size chunks known as the sectors. So sectors are the basic storage units of the data. The usual size of the sector is 512 bytes. This is taken as a standard. The sector on each of the track will have the same capacity. If you can see with the diagram that if this is a circle, this part or this sector will have large area and this sector will have a small area. Since the amount of data that is going to be stored in each of the sector is same, the data density will be less in the case we are dealing with the sector on the outer tracks, and when we are moving inside, the data density increases. So data density is high on the inner surface or inner track, on the inner tracks. Fine. The total number of sectors on each of the tracks remains the same. Now, same track numbers usually form a virtual cylinder. For example, if I number the track numbers as 0, 1, 2 and 3, then 3 number track of one surface, 3 number track on the other surface and 3 number track on each of the surface will be forming a virtual cylinder. Similarly, 2 number tracks on each of the surface will be forming a virtual cylinder, and one number track on each of the surface will also be forming the virtual cylinder, and the data is stored in parallel on these cylinders. Since the head is fixed, head is there for each of the surface, the location of the head will be same for each of the surface at any given point of time. So, let us utilize that as storage purpose in parallel. Now, we have seen that whenever you have to store the data, so data is divided into the equal size chunks. So, those equal size chunks are actually the 512 bytes data, and these chunks are considered as the increasing or a kind of the array which is storing the different blocks. So, we can consider that this disk blocks is an array of 512 bytes blocks. The data storage starts from the 0 number track and onwards. It means that the 0 is the outermost track and the innermost tracks are when the number increases, we are moving inside the tracks. For example, if I have this track, the 0 number track is towards the outer side, 1 is inside, 2 is even inside, 3 is inside, and so on and so forth. So, the data will be stored on the tracks, and we start storage of the data from the track number 0. Now, we have also seen the various times related to the disk access. For example, if there is a head and head is moving, so it will take some time for the head to locate to the data, and the data may be there on some portion of the hard disk surface. So, wherever the data is, let us first locate the track. So, for locating a track, whatever time is required, or from wherever the disk head is right now to reach to the desired track, how much time is required is known as the seek time. Similarly, the disk is moving with a constant speed, and it will take some time for the desired sector to come in contact with the read write head. So, it will also take a time. So, this also is known as the rotational latency. This is known as the rotational latency. Now, after reading the data from the hard disk, it will take some time for transferring of this data to the RAM. Hence, this is known as the transfer rate, and collectively seek time plus rotational latency and the transfer time is known as the total disk access time. So, now today we will discuss about various disk scheduling algorithm, because the operating system can govern the movement of the hard disk read write heads. This is also known as the disk arm. So, the movement of the disk arm can be controlled by the operating system, and the various algorithms for doing so are first come first serve, shortest seek time first, scan, cscan, look, and the clook algorithm. So, let us see all these algorithms one by one. What happens in the case of the FCFS, that whichever request is coming first will be served first. For example, if I have the disk request as 98, 183, 37, 122, 14, 124, 65 and 67, these are the disk request, means these are the disk request for a particular track. It means my data is there on these tracks. So, whenever we have to read the data, we will have to move, or we will have to go through these tracks. We means the head will have to reach to all these track numbers. Okay. So, currently if I consider that my head is at 53 number track, then these requests will be satisfied as with the first come first serve scheme. 98 is the first request which has come. So, I will move from 53 to 98 first. Next request is 183. So, I will move from 98 to 183. Then 37 is the next request. So, the disk head will move from 183 to track number 37. So, this is 37, I am sorry. Okay. Now, the next request will be, let us take it 41 only. The next request is 122. So, from 41 I will go to 122, and then next request is 14. So, I will move from 122 to 14, and then 124 I will move from 14 to 124, and then next request is 65. So, I will move from 124 to 65, and finally, I will move from 65 to 67, because 67 is the last request. So the movement of the disk arm is dependent on the request that we have got. The first request is satisfied first, the next request is satisfied next. We don't have to see, or we don't have to apply any other logic. The only logic is that first request will be satisfied first and second request will be satisfied next. So we, in general, whenever this kind of the arrangement is there and we are solving this with the help of the diagram, on this is also known as the Gantt chart or the timing diagram, we actually have to find out how much total movement of the disk arm took place. So with this you can see that the total movement will be 98 minus 53, because the disk arm has moved from 53 to 98. The next movement is from 183 to 98. So just add these two, 183 minus 98, and then you have to move from 183 to 41. So you will have to subtract 183 minus 41, and then you have to go from 41 to 122. So this will be 122 minus 41, and then you have to go from 122 to 14. So this will be 122 minus 14, and then you have to move from 14 to 124. So this will be 124 minus 14, and then you have to move from 14 to 124 to 65. So 124 minus 65, and then you have to move finally from 65 to 67. So if you add all these things, so this is the total number of movement the disk arm took place while moving and serving the request with the first come first serve scheme. So if I just take this figure, so this will be 45 plus this will be 85 plus 142 plus 81 plus 108 plus 110 plus, if you will subtract this, you will find 59, and then this is 2. Added all together, this will be the total number of movements that the disk arm took place. Okay, this will come out to around 600 something. Fine. So 600, around 600 movements are taking place for moving like this, or in fact if you find out the complete value, this will be 5 plus 5 10, 12, 13, 21 and 11, 31. So this is 631. So 631 movements took place for performing so. It may be wrong also, you should go actually with the calculator to solve this. Now the another scheme is the SSTF. The SSTF scheme suggests that you already have a request, you know the current position of the head, you find out what is the least distance of the read write head which is currently there and the request. So you find out which is the nearest request to satisfy, and you go there and satisfy that request. After serving that request, you again have to see which is the nearest request and satisfy that. Similarly, we will be satisfying the request on the basis of the distance. For example, if these are the requests which have come, once again let us take it 41. So if these are the requests which has come and the head is currently at 53, so you can see that from 53 you have these requests, you arrange all these requests on the timing diagram and you just see that which is the nearest request to 53. So from 53 there is a request 65 and 41, both are at a distance of 12, both are at the distance of 12. In case the disk arm is moving in the upward direction, then you solve like that, or if in case you find out any discrepancy, just remove this and take this as 37. So now 53 से 37 की distance ज़्यादा है and 53 से 65 की distance कम है. So we will be going towards the 65. So from 53 we are going to 65. From 65 the nearest one is 67 because it is only 2 distance apart. Now from 67 we have two options, either to go to 98 or to go to 37. Okay, so this is 31 and this will be 30. So you can go from here to here, which is at a 30 distance. Now after 37 you have to find out which is the nearest request. Obviously 14 will be the nearest request, and then from 14 you find out which is the nearest request. All the requests are on the right hand side. It means 122, 124, 183, 199. 199 is not the request, this is the largest track number. Okay, so obviously the nearest one is 122, 98 sorry. So you go to the 98 and satisfy this request, and then after 98 122 is the nearest request. So you go there and satisfy that. From 122 124 is the nearest one, so you go there and satisfy that. From this to 183, this is the last request, and this is the nearest request to 124. So whenever you have a request, you analyze that which request will be nearest one to the disk read write head currently. Okay, and finally the total movements that you can find out, we are doing just a shortcut. 67 minus 53, it is taking the distance from here to here, and then from here to here the distance will be 67 minus 14, and then from here to here the distance will be 183 minus 14. So the total distance will be 14 plus 53 plus 169. So altogether it will be 4 plus 3 7 9 16 236 is the total movement of the disk arm, or the disk arm had to move these many tracks, or the disk arm had to travel to these many tracks for serving the request. Now with the help of the FCFS scheme, we have seen that 631 movements were required. In the case of SSTF only 236, so it has reduced to 1/3. But what is the overhead? Because of the upcoming request, you will always have to find out the minimum request. So this is just the overhead, that you have to find out the minimum distance. So finding the minimum can be found with any algorithm, but this is the overhead with the SSTF algorithm. Now the another algorithm is the scan algorithm. This can also be termed as the elevator algorithm. You must have seen a lift which goes from the lowest track or the ground floor to the top floor, and then it comes from top floor to the ground floor. So when it goes from ground floor to top floor, it takes the people and it drops the people also. And similarly, while coming down, it takes the people from the different floors and drops the people at the different floor as well. So this the same is the concept here in the scan algorithm. The disk arm will be going from the lowest number of the track to the highest number of the track, and then it will be coming from highest number of track to lowest number of track. While going up, it is satisfying the request, and while going down, it is satisfying the request. So let us take the example and understand this. Let us take it as 37 only. Now the requests are these ones, and the current position of the disk head is 53. It is assumed that the disk arm is moving towards the higher number of tracks. It is just the assumption. It may go from the downside also. So then you will be doing the computation accordingly. Here we are assuming that the disk arm is going towards the higher number of the tracks. So since it is going towards the higher number of the track and 53 is the current position of the head, it will first go to satisfy 65, then 67, then 98, then 122, then 124, 124, 183 and up to 199, because it is going from the ground floor to the top floor. Similarly, here also, here we are assuming that the track numbers are from 0 to 199. There are 200 tracks. So the lowest track number is 0 and the highest track number is 199. However, the highest request is 183, but even then the disk arm will move towards the highest number of the track. So it goes up to 199 and then comes back towards the lower number of tracks and satisfies the request. So towards the lower side we have 37 and 14 requests. Okay. In general or in practice, the disk arm will be coming to 0 track, but since my requests are finishing up to 14, we will consider that my computations can stop there at the 14. So the total number of the movement that you find here will be 53 to 199, means 199 minus 53, and then you add 199 minus 14 with this. So this comes out to 144 plus 185. So 339 is the total number of the movement, or the disk arm has to move these many tracks for satisfying all these requests with the scan algorithm. Now, there is a variation of this scan algorithm. This is known as the C scan. Let us understand this very easily. It is like the elevator is moving up and satisfying the request, but when it is coming down, it is not satisfying the request. So, when it is moving up, it is satisfying all the request. When it is moving down, it is not satisfying the request. So, the disk arm is moving from the lower number of the tracks to the higher number of tracks while satisfying the request, while coming back from the higher number of tracks to the lower number of lowest number of track, it does not satisfy any request, and then it again goes up and satisfies the request. So, what is the concept here? That we are considering that the track number 0 is considered to store the location or the physical location of all the request. So, whenever the request will come to us, then we should be transforming that request to the actual or the physical addresses. So, the physical address here in the case of the mass storage or the hard disk is the track number and the sector number. So, for any of the request, the track number and the sector number information or the volume level information is available, or the directory level information is available at the track number 0. So, when the disk arm is at track number 0, by then whichever request have come, it will be converted to the track number and particular track number, and disk arm goes up and satisfies all those requests. So, when it is moving down, it will not have the information of any of the other requests which have come in between. So, it has to come to 0 number track, find out the other requests which have come till then, and then it again goes up and satisfies those requests. So, the process goes like this. So, in the C scan, let us take this as this example only. Let us take this as 37. The disk arm is currently at the 53 number of the track, and then it is moving up and satisfying the request. So, whichever requests are coming in between, it is satisfying that, and it will go up to 199 number track. And when it is going down, it is not satisfying any request, so it goes down up to 0, and then it once again goes up, and whichever requests have come by then, it will be satisfying those requests. So, my requests are finishing at 37, so my computation will also stop at 37. So, 53, 199, the movements which have taken place is 199 minus 53, and then from 199 I am moving to 0. So, 199 minus 0, and then from 0 to 37. So, the total movements which have actually come will be 146 plus 199 and plus 37. If we sum this, (382) total distance had to be travelled by the disk arm for satisfying all those requests. Now, look algorithm is actually the variation of the scan or the elevator algorithm. What does the look algorithm do? In the look algorithm, we are considering that the disk arm will move from the lowest request number to the highest request number. Similarly, from the highest request number to the lowest request number. It is not going from floor number 0 to the topmost floor. It is going from the floor which is or wherever the lowest request is, and then to the floor where highest request is. The usual lift also goes like this only. So, this is a variation of the scan algorithm. Let us see it with an example that will make you more clear. So, once again we are taking the same example, and in the same example the disk arm is currently at 53. So, while it is moving up, it is satisfying the request. The last request is at 183. So, the disk arm will not go from 183 to 199, it will stop there, and then it will come down, and in case there are requests, it will be satisfying that. While going down, it is satisfying the request only up to the last or the least request. So, the total movements that it had to take place in doing so will be 183 minus 53 and then plus 183 minus 37, sorry 14. So, the total movement it had to take place will be 130 plus 169. So, 239 is the total number of the disk arm movement that the disk arm had to take place, the disk arm had to travel. So, total effort taken by the disk arm to move and satisfy all those requests is 239. Now, the last one for today will be the C-look algorithm. The C-look algorithm is very simple. In the C-look algorithm, this is actually the variation of the C-scan. in the C look algorithm, the disk arm moved from the lowest number track to the highest number or the lowest number of requests to the highest number of requests. When it is coming down, it is not satisfying the request. While coming down, it is not coming to the lowest number of track, but it is going to the lowest number of the request, and then it will go again and satisfy the request, but it will go only up to the highest request number. For example, in this example what we are doing that disk arm is currently at 53, so it is moving up, so it will satisfy the request. So it will satisfy the request, all the request which is falling in between, the last request is 183. So it will stop there and will change the direction. So while changing the direction, it will go to the minimum request 14, it will satisfy that, and then it will again move up and will satisfy the request. So the last request which is coming is at 37. So the movement will stop at 37 for this particular scenario. So the CLOOK algorithm is just a variation of the C-scan algorithm. It is going up and satisfying the request to the maximum request, and then coming down to the minimum request. It is not satisfying the request, but once again when it goes up, it satisfies the request. So while going up, it satisfies the request, while going down, it does not satisfy the request. So the total movements that has taken place in this case will be 183 minus 53 plus, from 183 it has gone down to 14. So 183 minus 14, and finally it has gone from 14 to 37. So 37 minus 14. So this entirely is 130 plus this figure will be 169, and then this figure will be 23. So whatever is the total number of the movement that the disk arm took place. So we will see all these things with an example as well. We have seen already the various algorithms for doing so, and the numerical is saying that this particular numerical is saying that this cylinders have the requests are 47, 38, 121, 191, 87 and all these, and the disk arm is currently at 63. So the FCFS algorithm will, what the FCFS algorithm will do, it will see the first request. So from 63 it will move to 37, and then from 37 it will move to 38, from 38 it will move to 121, from 121 to 191, from 191 to 87, there 11, and then 92, and finally the 10. This is the FCFS. The SSTF algorithm will compare the minimum distance of the 63 from the various requests. So whichever request is the nearest one to 63 will be satisfied, and then in the next go we must have reached to some location. From there it is seen what is the minimum request distance, and so on and so forth. In the next term, on the next term we will see so many questions related to the disk scheduling algorithm, and we will see that some of the questions which are frequently asked in the GATE examination. So this is the reference for today's lecture, Operating System Concept by Silverschads and Galvin.